Morning, everybody. Thank you very much for coming. So as Rachel very kindly introduced, my name is Ben Widdowson. I just want to quickly give you a little bit of background to myself without going into too much detail. So I trained as a design engineer using things like SolidWorks, which is probably not so good now we're part of Siemens. Very interested in visualization. And when I first left university, I got a job as a furniture designer. And after 6 months, we released this product with Argos. And I was very excited to pick up multiple Argos catalogues, give them out to my family and say, look, this is my work. So I was really excited to see how it did in terms of sales, and unfortunately it was a complete flop. And I think that was possibly mainly due to the instructions, which are an interesting design visualization challenge, and clearly these ones were a massive fail. But ever since then I've been really interested in how designers communicate their ideas, all the way from 2D sketching right the way through to modern technologies like VR, which has kind of led me to where I am now. So we've been in a very privileged position over the last few years to speak to many designers, particularly in automotive teams. And what I'd like to share with you first is some of the kind of key challenges that we've heard that designers experience in this kind of modern era of visualization. So a couple of the things we hear is that they don't have enough time to evaluate all the ideas and themes that they would like to, i.e. they'd like to spend more time being creative, and this is partly due to constraints around having to deliver ideas to senior management and sign things off and move them forward. When it comes to visualizing ideas, they often say they have to spend too much time manually preparing data, whether that's for 2D renders or for some of the newer technologies like VR, which we'll come on to in a moment. They also say due to some of these limitations, their iteration cycles are too low, so the time it takes to go from an idea to review it with an exec, to come back, refine it, that kind of whole process is very slow, and they'd like to be a lot more agile. Obviously, big CAD data sets are very, very large, and particularly when you get into areas like VR, this is a big challenge to make things run performantly. And then finally, particularly in big manufacturing companies like automotive heavy industry, they make a lot of physical prototypes, and whilst there's obviously a very, very important place for these, they often complain that they have to make too many and that they take too long, and they'd like a better solution. So I'm just going to unpick a few of those a bit more. So particularly on the evaluating design themes, when you're at this kind of end of the design process, it's often a lot of sketching, a lot of ideation, and we often hear that people come up with hundreds of ideas at this point, but very, very quickly they have to refine them down to get through the process. And what we hear is they'd like to spend more time refining these ideas at this point, being more creative, but the limitations of time and budget and getting products to market really kind of stifles that. When it comes to doing design visualization, people want to get very, very quickly from sketches into models into something that looks compelling. And purely spending that time creating and optimizing the models is a long, long time. It takes a lot of effort, which naturally means that a lot of the ideas get filtered out very, very early. Typically, people want to go from something like this to something like this, which particularly when you're in something like VR is, it takes a lot of effort to go from heavy CAD data into something that looks really, really compelling in VR. And this is one of the areas where they'd like to improve. So this is a quote from one of our automotive customers. So they're modelers, the designers who are very well paid, very creative, very talented. They're paid to be creative and create designs. What often happens is they spend about a day a week just manually stripping down CAD data to do design reviews in VR or in stills. And we just thought this was just bonkers because they're paid to do something very specialist, and they're wasting their time doing very kind of manual, laborious work. We've talked about the iteration cycles already, so I'll move on from that one. The prototypes is quite interesting. So when they get down to further stages of the design process, often they will do something like this, where they're milling a product out of clay or fabricating something. And what often happens is by the time they send the data over to have it produced, not only does the process of building it take a lot of time and cost a lot of money, but often the design has moved on. So when they come to review this product in 3D, in a physical product, there's already a number of changes which have happened to it, so it's kind of redundant and out of date. So it's a big challenge, and we hear that things like this cost about 200 grand a pop to make, take about a week to mill, and then manually scrape. So there's clearly huge benefits in having a physical model, but we hear that they would like to iterate more quickly and do less prototyping at this kind of level. This is quite an interesting quote from another one of the automotive customers we worked with. So currently they do 90% of their design reviews using a clay model. As I say, each one takes about a week to mill and hand scrape, and it costs around 200 grand. And what they would like to be doing by 2020, and this quote was a few years ago, so I don't need to check in on whether they got there or not, but they would like to be doing 10% of those reviews with a clay model and 90% of them in VR. So what they're really saying is that they want to iterate more quickly, review things more quickly, and build the models at the right time. So specifically, as we're talking about VR, I'd just like to pick up on a couple of the challenges that are faced around VR today, and there'll be people who are more familiar with this and more learned than I am, but this is a kind of, albeit slightly outdated, but the kind of typical view of VR is that it's, there's a big headset on your face, it's a bit clunky, it's a bit techy, there's lots of wires, things like resolution on the screens are not quite where they need to be, tracking, when you're doing things like exec design reviews, there's often that thing where they don't want to have a headset in front of them and stand in front of people and present because they feel stupid. And also they still require a huge amount of processing power to get the kind of visual fidelity that some of these companies want. So, we can see the direction of travel it's going in, it will get there, but currently there are limitations around VR. And as we've explained, it takes a lot of effort to get your CAD data prepared for something in VR. So that kind of begs the question, why do people bother? Well, this is a quote we heard a few years ago, that ultimately they want to be able to confidently sign off a design in VR, which I think is a really powerful statement, because it kind of shows that they really want to do this, and that they're willing to spend the money and take the time and let the technology mature. So if people can reduce the amount of time it takes to get their data in, then obviously they can spend more time being creative, as we discussed. If they can iterate faster and do more design themes, come up with more ideas, then ultimately you're going to end up with better products and better designs. VR is an incredible tool for collaboration. So if you think about teams that have got offices across the country or across the world, if teams can collaborate in VR in a shared environment, then again that adds to creates better designs, better decisions. And if ultimately they can sign off a design theme in VR, I think that's a really exciting place. So one of the things we often hear is that to get to that point, it has to be really simple. We don't want to be doing any manual data prep, i.e. it has to be automated, and it has to look visually compelling or visually stunning. So there's plenty of tools where you can launch VR straight out of the CAD, and that's great, and it definitely has its place. But for the kind of use cases we're talking about, they need it to look as close to photoreal as possible. So these are the kind of constraints that we're working in. So over the last couple of years, traditionally our background is in kind of high-end photoreal ray tracing, and we've seen more and more competition from the game engines, things like Unity and Unreal, and people using them for use cases where traditionally they would have just done stills or animations. So over the last couple of years, we've been building a solution called Slipstream, which is designed to solve a lot of the problems I've described earlier. It's designed to enable designers to automatically take their very, very rapidly changing CAD data automatically into a very high-end visual VR design review experience that's multiplayer. So I'm going to show you a quick video that just summarises some of this. So I'll just stop that there. So really this is a tool that we've been creating that's very focused on designers. I list a couple of industry sectors here that we've been working with already, but really it's for kind of any industry that's got a lot of heavy data that's changing very quickly and they need to review it in a very kind of visually compelling way. So everybody asks how does it work, and I could go into a lot of detail about this, and we've got a lot of the team who'd be willing to go into a lot more detail than I can give you. But fundamentally, we want to make it very simple to take rapidly changing CAD data, get rid of all that manual data prep, and provide a kind of simple, stunning output at the end. So fundamentally, that's how it works. To dig down a little bit deeper, what we're doing is taking the kind of source input CAD data from customers, whether it be from something like Siemens NX or in the design studios use things like Alias. We're ingesting that data into a pipeline that we write for the customer. We do a lot of processing of the data in this kind of Slipstream processing bit. That's where most of the clever stuff happens. We convert all that CAD data into game engine assets. So this is all stuff that happens before it hits the game engine. And then once we drop it into the game engine, we do things like applying materials, baking lighting, and building a game. And the output of this is that the customer never sees any of this happen. They just click a button and they get the output result at the end, which is an executable that they can double click on, launch into VR, and start reviewing their products. So the goal of this, as I say, is to kind of strip out all of this stuff they're doing manually and automate it so that they can just get from start to finish as quickly as possible. So I'm just going to unpick a few of the kind of key benefits that customers have told us they like. So one of the things is simplifying that workflow. So rather than going in and out of lots of applications to have to do all the setup and getting into game engine development and setting up environments, all that kind of but somewhat complicated stuff, we really want to simplify that workflow so that you can go from A to B as quickly as possible. The second key thing I've mentioned is automating a lot of that actual data prep for the geometry. So as I say, behind the scenes, you can go from very, very complex source CAD data all the way through to something that looks visually compelling at the other end. One of the things we found from doing a lot of these projects is that when we started, we would often try and use a very generic sort of studio type environment for customers to look at their products in. The feedback we got is, well, our designers are in there and it's not the environment that they review the real products in real life. Could you create a model of our design studio or our courtyard for us to review things in? And we said, well, that's interesting. Well, why do you want that? And they said, well, because then they can focus on the product and not worry about the weird lighting you've got in your studio that they've never been in before. So what we found is that every customer we're working with, we're actually helping them create a kind of 3D VR ready model of their studio or their courtyard, and these appear as kind of levels in the experience. And often the feedback we get is more about, well, the lighting or the leaves don't quite look right on the trees in our courtyard. Could you fix that? But that kind of says to us, well, at least the product's looking good, so that's fine. But yeah, having these kind of familiar environments means that the designers are more comfortable. They can focus on designing and refining the product rather than the environment. Another key thing, which again we just thought was a kind of given, is multiplayer. So being able to provide an experience out of the box where customers from different sites, different locations, different teams can all jump into the same experience and review their product together is actually incredibly compelling. So a few weeks ago we had some execs from Siemens over visiting a customer hack rod whose data you've seen all over this presentation. So there was a few of them in their studio in LA. There was a couple of guys in the UK helping from our end, and there was another guy elsewhere in the States, and all three people from different locations across the Atlantic were all in this shared VR experience. And I'm told that they spent about an hour actually messing around in VR, which for us says that it's kind of doing its job. And then this is a funny one. So the fewer prototypes is obviously a kind of really, really important thing. There's definitely a place for physical prototypes. As I mentioned, with the limitations of VR, we're not at the point where you can, like Ready Player One, just jump in and kind of touch and feel things that look visually compelling. We're still a way off that. But in the meantime, customers wanted us to actually add clay shaders to the VR models, which was a bit bizarre, but interesting nonetheless. But we think that it's a technology that supports physical prototypes, not replaces it. So I just want to quickly touch on a couple of future developments and things that we're working on at the moment, which I think are really interesting. So it's one thing to jump into VR and see a virtual car. That's great. You can kind of walk around it, but there's nothing really to interact with physically. One thing that we've been exploring with a couple of customers recently is this concept of having a kind of aluminium frame with some like seats, door frames, steering wheels, etc. And what a lot of companies are experimenting with is actually even 3D printing door panels as they're designing them, or dashboards as they're designing them, and they'll fix them to these kind of physical bucks. And what we've been helping them do is to actually set up and automate the data input for some of these trackers. So HTC, for example, they provide these 3D trackers you can affix to things. And what this enables you to do is have a physical buck in the environment that you can walk around. And when you open a door in the real world, it opens the door in the virtual world. When you sit in your seat, it's all tracked, so you can recline, rack it back and forward, adjust your seating, adjust the steering wheel, and it all replays back in real time in the game engine, in the design review experience. And we think that this all leads to a really, really, really compelling experience for designers, where you can actually reach out and touch certain things, and it just adds that another level of kind of immersion into the experience. So we're not selling these bucks, we're selling the kind of way to get the data in and have it all perfectly aligned and all tracked. So hopefully we'll have a bit more to show on that later in the year. Just to close, a little bit about Lightworks, now part of Siemens. We joined the Siemens company about 4 or 5 months ago. We have a really eclectic mix of designers, game engine developers, software engineers. We have a lot of experience in visualization, and over the next few years we're looking to really kind of cement some of the things we do within the Siemens products. Got quite a cool place to work as well, so anyway, Sheffield's welcome to come and have a look, come and see some of the demos. So we have 4 main products. One of them is the iRay SDK. Anybody who's heard of iRay, that's a rendering engine. So we license that to CAD companies to do photoreal visualization within the CAD engine, within the CAD systems. We've also developed a number of iRay plugins, which we sell via iRay plugin store. So that's things like 3D Studio Max and Maya. We've talked already about Slipstream, and we do some interesting kind of custom configurator projects for big customers like Gulfstream, which are quite exciting as well. So that's everything from me. We have a demo down on the show floor with some glamorous members of the team helping show that off. So come and have a go. And if you've got any questions, here to help. Thank you very much.